Well, hey everyone, as you can probably tell already, another XCarve video, yeah, and there have been a few. I'll say up front, this was sent to me, I haven't had to pay for it, anything like that, but my side of the bargain was I would produce a genuine, honest, kind of a walk around of the machine. It's got the drag chains, the limit switches, oh, the upgraded motors as well. It's got the bigger stepper motors. The only kind of issue I had with the whole delivery procedure was the fact that it was held up for quite a while at the UK end of customs. You might have a better or worse experience with that, you know. So in terms of packaging, the whole lot came packaged really, really well. I didn't have any missing parts. On the contrary, I actually had a few extra parts. Bolts and washers left, a couple of grub screws, one flat washer, the header connectors, terminal connectors which are used with the limit switch stuff and some of the electronics, and that was really good actually. Well, I managed to mess the first one up completely. I don't know, maybe a dozen of the threaded inserts which go into the wasteboard. The wasteboard actually comes packaged separately to everything else. I'm kind of ambivalent towards the wasteboard. It's really helpful having all the pre-drilled holes in the inserts and obviously the clamping points and extra things like that, but it's kind of an expensive piece of 18mm MDF, if I'm honest. MDF being what it is, it's quite heavy, so you've got a relatively expensive item with a relatively expensive shipping cost, and then obviously any locally associated import duties, tolls, taxes, whatever. So I think the cost for a wasteboard to buy is about $140, $150, something like that. It was about 100 and something just for the shipping, and then there was about another £40 sterling to add for the import duty, which basically makes it a very expensive piece of MDF. And actually, if you went down to your local supplier, you could probably pick up a metre square sheet for about £7.50, but then you haven't got the markings and you haven't got the waste holes. But actually, I think just a standard piece and screw it in for the sake of £7.50, you'd save quite a bit of money in all the shipping and all the rest of it. And actually, this could be better packaged, particularly for export. Now, it had two pieces of polystyrene on each end, a piece down the middle, and it was all in a cardboard box. When it arrived, the cardboard box did have a little bit of damage, and when I took the wasteboard out, there was a little bit of damage to one of the edges. I think it had been dropped or knocked or had something bump into it, and it kind of bruised the corner, so it's swollen out, which doesn't do anything cosmetically really because it was on the underside, but it needed a little bit of work to take that kind of swelling out so it would fit nice and flat to the extrusions. So had I had to pay for it, I would have been a bit miffed, to be honest. So that's something to consider. I know other people have had them shipped over to the UK with no problems at all, so you know, that's really a gamble, I guess. Another thing I want to talk about is the toolkit, which I think, if memory serves, has an associated cost of about $25, which isn't a huge amount. From a UK perspective, I think this is probably not worth it. Although I did use the parts from the toolkit, there wasn't anything that I didn't already have. And actually, the 7 and 8mm spanners, the Torx driver, the larger of the two screwdrivers, and the Allen keys were the only things that I used. I didn't even take, this is still in the packet, I didn't even take this out, and I've actually no idea what this drill bit is for because I couldn't see any reference to it in any of the instructions. I don't think I took the 13mm spanners out, but I've got the Acme lead screw rather than the threaded rod screw, so I think they're probably for that, and possibly the 10mm spanner came with the lead screw kit. So I'm not overly impressed with the toolkit. Not that it's poor quality tools or anything like that, they do the job fine, just because here in the UK these items are fairly readily available, and I think actually if you're in a position where you're going to be making something like this, or you do making stuff kind of projects, you've probably got Allen keys and a Torx driver bit. a couple of small spanners. So I think you could save yourself $25. If you don't have metric tools, then you probably do need this. It's not a bad toolkit, it comes in a nice little pouch, keeps everything in the same place. But yeah, if you know what this drill bit's for, then let me know, because I've no idea. Absolutely no idea. What is worth getting, if you haven't already got, are the verniers, because these are really helpful and actually pretty accurate as well for measuring your material thicknesses, and it also helped me to scale some of the projects as well and confirm that 25mm distance moved was actually a 25mm distant move. So the next thing that's worthy of a mention is the spindle. This is the stock 24-volt spindle. I've heard a lot of people say that it's too small, underpowered. I'm on the fence at the moment, I haven't decided. Now, you know, bigger is better, blah blah blah. So I haven't come across any major issues at the moment. The one thing I don't like about it is the fact that the actual spindle is quite long from the bearings to the point of cut. I mean, that's nearly, it's getting on for 3 inches, between 2.5 3 inches. So there's a lot of potential deflection there. So I'm not 100% sure how long the bearings are going to last on that. It is my intention to upgrade the spindle. The home point on the wasteboard, when the spindle is across, it doesn't actually meet that. Obviously it's quite a small spindle, so by putting a larger mounting on there, I think that's going to run to that. One thing that really did annoy me, you get two spanners with the stock spindle. One is for the collet nut, which is a nice fit, and then the smaller one is for the spindle itself, and it doesn't fit on there. What's all that about? That's no use whatsoever. So what I've been doing, just using a 14mm spanner, because I've got a 14mm spanner and I can't be bothered to sit down and hand file and fix the one that's broken. So that's just going to go in the bin. Which is a shame, but you know, how difficult is that to do? Kind of moving on to the electrics. The limit switches only serve to home the machine. That's all it does. It doesn't stop it. So don't think it's going to be an emergency stop. You home the machine, and then you tell the machine, you actually tell the machine which size you've got, whether you've got the 500 or the 1 metre square. So it should know from home how far it can travel. At the moment I've found, I don't use it very often. I seem to be putting rather than putting all the work down in this left hand corner, I've been putting it further towards the middle. You can kind of gauge how big, you know how big your piece of work is, whether it's going to fit or not, whether it's going to carve into that. And the way Easel works and gives you your dimensions and gives you a visualisation of those dimensions, I don't think that's a major problem. So to be honest, I don't think the limit switches are really worth having. I haven't found them more useful than not having them. So unfortunately for me, limit switches, I'd save money on those and buy a few extra cutters maybe. I didn't have an issue doing any of the electrics at all. Even the soldering for the little terminals onto the G-shield. I tinned all the ends of the exposed cables before connecting them to where they had to be connected. Just because, well, I've got a soldering iron out, I might as well. The cabling, this piece of cabling with it all bunched up is actually quite rigid and quite stiff. And I have noticed a couple of times these have become loose. A couple of times I've gone to use it and it wouldn't move in one of the 3 directions, and it was a case of taking off the fan and re-putting these in. And what it needs is a bit like a normal UK 3-pin plug. You get like a little strap that goes over the cable to hold it where it goes into the plug, and that relieves the stress on these points. So I will be making some kind of case, and actually on the Inventables website somebody's already done that and left the plans on there, so you can just download those and carve a box. But they will definitely have some form of fixing this to the case to relieve the pressure on these. When you are wiring it up, it does say in the instructions at some point to label which cable is which for when you pull it through the drag chain. Now I actually did that before getting to the point where it said to mark them up. So I'd actually individually marked each cable before I put it through the drag cable, because it was just easier to trace it back and go, oh, that goes to that step, so that's X or that's Y or whatever. So I'd advise, if you're building one, then mark the cables both if you're putting limit switches on, mark which limit switch it is, X, Y or Z. Mark the stepper motor cables up as well once they're connected to the various motors, because it just makes life a lot easier down the line rather than trying to trace it through, looking through the little slots in the drag train or stuff like that. Okay, so the next notable thing is the sort of box itself, and just taking the screws out to expose inside. What you've got is the G shield, which mounts on top of the Arduino, and when you fit the two together, there's a load of pins, a bit like these pins that are sticking upwards, sticking down, which fit into sockets on the Arduino. Now that's all well and good, but the Arduino is bolted to the bottom of this metal box, so you have to bolt the Arduino on and then drop this in, and it's a very tight fit. I actually had to file just a hair off this edge here to be able to get it past this lip and this lip here and slot it in. Now there's been a lot of chatter over the internet about people with damaged G shields and things like that. Now I'm not making any accusations, but I found it quite difficult to get the two lined up because you haven't really got much. There's a lot of pins that need lining up, and there's not a lot of visibility to carefully get it in. So that's quite a fiddly operation. It's not technically difficult, but it's very fiddly, I found. Basically watch out for that. Also I found, mostly because of the way I tinned it actually, it was pretty difficult to get these two black terminals into this. I think they're the ground terminals for the fan and the spindle. I think they're for. So some of these are more difficult. Really, the only other thing to mention within this box is these little potentiometers for the stepper motors. I actually had to adjust the voltage on the Y stepper motor, because there's two of them. I suspect that they're drawing more power than the circuits where there's only one, so I just had to increase the voltage. Basically it's about 1/8 of a turn a time, so sort of 45-degree increments to step it up, because what I was finding, it wasn't moving in the direction it should be enough in the Y axis. So I started off where the hole was too far down and over the slot, and then by increasing the voltage slightly, sort of just moving it up and then moving it further up, and then I got to the point where this one here was actually cut several times. Rather than cutting all the way through in one machine, what I did was I ran the program several times but told it only to cut down a small way, so each cut was overlapping to check that it was consistently cutting in the same place. So all in all, the actual build process, as I've already said, was pretty simple. I did kind of stray away from the given instructions and do them in a slightly different order, in so much as I put the base section and the baseboard together pretty much straight away and used that as a table, because as you can see, the table this is now sitting on is not deep enough, because this is a colossal machine. Even though I can measure what a metre is, it still didn't really register just how big the machine was going to be. So that's something definitely to consider. Absolutely got to make sure that you've got the room for it. The only issue I had with putting the baseboard together before it said and building everything on top of it was putting the spindle onto the Z maker slide, and actually that was pretty simple, in so much as this whole unit gets put together, and then I was able to, rather than put it in from underneath as the instructions said, as a whole unit, you can actually slide it straight down from the top. I think I'd probably recommend other people to doing it that way rather than necessarily following the instructions to the letter. I didn't really have any major issues with the way the instructions were set out. They were clear. I didn't have any issues with identifying part numbers to individual components. I actually didn't even have a problem with putting the tap screws in. It was a little bit of hard graft by comparison, but by no means was it a a difficult or unpleasant task. So use a bit of cutting fluid. I use 3-in-1 oil. As far as the design goes, one thing I've done on where these grippy track thingies, I can't even remember what they're called now, where they fix on at one end, you've got the adjustment, so you can tighten them up as they loosen. And as you can actually see, I haven't cut mine right down. You can actually see the bottom bit under there. A little bit of heat shrink tubing. I haven't even bothered to shrink it. It just gives it a little bit of extra grip than the original design plan. I've also added these little cable ties. I would like to see that bolted in there, actually, probably rather than the way that it's bolted in. It probably doesn't need it, but a bit of peace of mind. So that kind of brings us to the software. I'm going to cover Easel software in another video, purely because I don't want this to get too drawn out and boring. So this isn't a particularly difficult project to build, really, to be perfectly honest. There's loads of support from Inventables in the form of the instructions, which I found fairly clear, fairly self-explanatory. And if you're the sort of person who would be interested in building something like this, then you're probably going to have the sort of aptitude where you can follow instructions. You can probably pick up soldering relatively easy. All of the little points that I picked out, the heat shrink tubing on the tracks, plastic cuffs instead of nuts and bolts, a spanner not fitting, a bit of damaged wasteboard, a few other little niggly things. Again, if you're interested in following through with something like this, that's not really going to be a major issue. And to be perfectly honest, you can build around those problems and you can modify them yourself. The bottom line is, it's an open source machine. So you have a load of components and a load of software, and they're simply put together in a way that, I could quite easily cut these tracks down into 750 and have a 750 by 1 metre machine if I so chose. It's my understanding actually that Inventables do longer maker slides, up to about 3 metres I think. So you can build a bigger machine. The software's the same, the components put together is exactly the same, and you can customise the whole output to your needs. Because it's a self-build kit, you've put it together, you understand which bits work. So if something does go wrong, if there's a loose connection somewhere, it's quite easy to trace it back and that wire's for that connects there, that connection's loose or needs replacing. You can do all that sort of stuff. So you've got your own help and support from the knowledge that you've got from the ownership of building it in the first place. And that's, to my mind, a much better investment than laying out a whole load more as it would cost if it was an off-the-shelf plug and play item. I'm actually quite impressed with the machine in terms of what you get for your money, and that's not just what you've got sat here now, but it's kind of future-proof as well in some ways, so that you can upgrade the spindle. In theory, there's nothing stopping you putting a laser burner head on there instead of a router, and you've got a laser cutting machine. The possibilities are a lot more than just buying a single tool for a specific job, and that's what this is, the tool for working materials, not just wood, metals, plastics, wax. There's loads of stuff. There will be other videos on this. I'll probably put those in a Router 103 series for CNC work. I'd be interested to hear your views and comments, and actually, what do you think? Do you think it's woodworking or not woodworking? I'm certainly excited to work with the machine, with the company, and all the possibilities that that this brings, not just from an interest point of view, but potentially from a commercial point of view as well. So stay tuned for other videos. Don't forget to like and subscribe. We'll be seeing you back here in this particular setting for more of these videos and more of these videos, and I'll see you back in my own workshop for some more traditional projects as well. We'll see you next time.